So hello everyone. In this virtual lab, we are going to design that astable and monostable multivibrator using 555 timer. So 555 timer is one integrated circuit that is widely used for time-related application. So it is 8-pin IC. It is commonly available as any 555, and also there are some other manufacturers. So you can see the pin diagram. The pin number 1 is the ground. Pin number 2 is called trigger pin, where you can apply some external input. We are taking output from pin number 3. Pin number 4 is used to enable or disable the IC, that is reset. And if you apply a low signal, that means if the reset pin is connected to ground, then the IC will not operate. So for normal operation, to enable the IC, you have to connect pin number 4 with some positive voltage such as VCC. Pin number 5 is called control pin. Pin number 6 is threshold pin. Pin number 7 discharge pin, and pin number 8 is the supply pin, that is VCC. So you can apply the power supply of 5 volt to 15-20 volt. Generally, it is specified by the manufacturer. So there are different variants of 555 timer. Different manufacturers are there. Although the internal architecture is same, but there may be some difference in the supply voltage range. And this one is the internal circuit of 555 timer, where we have two comparator, op-amp comparators are present. Okay. And we have a voltage divider network consists of 3 resistors. And the value of resistor is 5K, so that's why the name is 555. And we have one transistor, so that is basically discharging transistor here, and the output is taken from that latch through one power amplifier, that is buffer. So we have one SR latch, okay, which controls the operation. So this is the internal circuits actually. So let us see how we can design different circuits, that is astable and monostable, using 555 timer. Now the 555 timer can operate in any 2 different modes. So one is astable, another one is monostable. Astable means there is no stable state. The output is continuously changing. That means output oscillates. Okay, so there is no stable state. Output continuously changes. Okay. So at the output, we can expect a square wave, that is pulse. And the frequency of the square wave depends upon the value of the resistor you are using in the circuit. That is, here you can see this is the astable circuit configuration. We are using 2 resistors, R1 and R2, and 1 capacitor, C. Okay. And you have to connect the circuit in this way. The R1 is connected from VCC to pin number 7, and R2 is connected in between pin number 7 and pin number 6. And 2 and 6 is sorted. And this capacitor, this is basically the discharging, charging, and discharging capacitor. It is connected between pin number 2 and ground. And pin number 1 is ground pin, that is, it is directly connected to this. And as I told you, that pin number 4 should be connected to power supply to enable the IC, that is the reset pin. Okay, so pin number 4 and 8, they are shorted together and they are connected to VCC. And we are taking output from pin number 3. Yes, pin number 3. Now check pin number 5. So it is a control pin. And note that when you are using the 555 timer, you have to connect one capacitor value of 10 nanofarad. That is 0.001 microfarad at pin number 5 and through ground. So it is used to eliminate any noise that is generated inside the 555 IC. Any high frequency noises are generated if any unwanted oscillations are there inside IC. So those frequency components will be bypassed to ground through this control pin. Okay. So it ensures the stability of the circuit. So it is recommended that you have to connect one 0.001 microfarad capacitor at pin number 5 and ground. Okay. Even if you open that for low frequency operation, output will be okay. But when you are working at high frequency, little bit higher frequency, the output may be distorted due to the presence of unwanted oscillations inside the IC. So better to use this capacitor. Now, just check the output we are getting. Here it is a square wave pulse. And this one is the voltage across capacitor. It just looks like the sawtooth waveform, a triangular like waveform. See the capacitor charges and capacitor discharges like this. and we are getting a sawtooth waveform. Okay. So this waveform is basically, if you connect oscilloscope across capacitor, you will get this waveform, and this output voltage pulse is taken from this pin number 3. And mathematically, we can derive the expression for that the time period and the on time t on, that is how long this output became high, that is given by this formula ln2 r1 plus r2 into c. So it is around 0.693 into r1 plus r2 into c. Similarly, how long that output will be low, this one, that is called t low or t off, that is ln2 r2 into c, that is 0.693 into r2 into c. And the total time period, that is on time plus off time, for any pulse, you know that the total time period is on time plus off time. So it is basically t high plus t low, and frequency will be 1 by time period. So you can calculate frequency by using this formula. And there is another one important parameter that is called duty cycle. So duty cycle is basically the on time or T high divided by the total time period. So T high by T high plus T low. So if you put this formula, you will get the expression R1 plus R2 divided by R1 plus 2 R2 in, okay, R1 plus R2 divided by R1 plus 2 R2. So this is the formula to find out the duty cycle. And in astable mode, okay, without any special circuit configuration for this general circuit, the duty cycle is always greater than 50%. Okay, so we cannot achieve duty cycle 50% or less than 50% using this common general configuration. You can achieve 50%, and you have to connect some other components such as diode across R2, and you can refer to any textbook for that. So let us design the circuit and simulate the circuit in TinkerCAD. So first, place all the required components. Now you can see the pin number 8. See, the power pin is connected to supply voltage. Let I am applying a voltage of 15 volt here. And pin number 4, this one is also connected to supply through this one. Pin number 1 is connected to ground. Now check the connection. The resistor R1, this one is our R1 resistor. Let I am taking a value of 10 kilo ohm. The R1 is connected between pin number 8 to pin number 7. Check 8 and 7. And another one resistor connected between pin number 7. Check the pin number 7 and pin number 6. This is R2. So we can take it like this. See here, VCC to pin number 7 R1, pin number 7 to pin number 6 R2, and 2 and 6 are sorted, and capacitor is connected to ground. So pin number 2, this one is connected here with pin number 6. Just check, and this capacitor is there, and it is connected to ground. And we have another one capacitor connected at pin number 5 to eliminate the noise, a denoising capacitor of value 10 nanofarad, and it is connected to ground. Okay. So let's pick up some value of this one. This is 100 nanofarad. Okay, fine. I'm taking the default value. Now let's connect the oscilloscope. Okay, so I am taking one extra ground pin here. This and this one, and this will be connected to pin number 3. This is the output we are taking. And this one will be connected to the voltage across capacitor. That means across capacitor means here we can connect. Yeah. So let's run the circuit. So let's adjust the time period, time per division. Yeah, it's too large. Oh. So now you can visualize the output, the expected output. This is the on time, T on. This is the off time, T off. And this is the voltage across capacitor, that is the charging takes place and discharging takes place. And we are getting the expected output similar to our theory like this. And from oscilloscope, you can measure the value of high, low, that is on time, off time, using this formula. Also, you can calculate it theoretically, and you can calculate what is the error you are getting from this. So this is all about astable operation using 555 timer. You can change the value of this R1 up to this capacitor. So of course, the frequency of oscillation will change. Now, in another case, that is the monostable operation of 555 timer. In monostable operation, there are only one stable state. For astable, there is no stable state. Output continuously changes between 0 and 1. But for monostable, the circuit will be unstable for some particular time if you apply some external input that is called trigger. So you can check the diagram. So this is the monostable configuration of 555 timer, where the circuit looks a little bit different, especially at the left side. But some part is common, that is pin number 84, they are connected to VCC, that is common, pin number 15, that is common, pin number 3 is common. So the difference is in the connection in pin number 6, 7, and 2 here, this side, okay. Actually, what is monostable? Monostable means the circuit is at a stable condition. Okay, so the output will be 0. If you are not applying any trigger pulse, the output will be 0. And if you apply some external input, that means if you disturb the equilibrium condition of the IC, then the output will be high. The output pin number 3, it will be high and it will remain high for some time. It is defined by this. So LN3 RC times, the output will be high. It is around 1.1 RC times, the output will be high if you apply a trigger pulse. And after this 1.1 RC times, the output will be again low. Just see here, what is the nature of trigger? Now see, when the circuit is at rest condition, that means the output is low. Make sure that the pin number 2 is at high. Okay, that means when you are not applying any trigger, the pin number 2 will be at a high position. Okay, that means you can connect it to 5 volt. And trigger means it's just a short duration pulse. So the IC will be triggered, the IC will be activated for a negative edge. That means when this negative, okay, that means when the output, this pin number 2 voltage will change, okay, and it is less than 2/3 of this VCC, then the IC will be triggered. And we see here we are applying a negative pulse. So for some time instant, if you connect pin number 2 to ground, so you can apply, you can connect one switch here at pin number 2, okay, where the switch, when you are not pressing the switch, the pin number 2 will be at VCC, some high voltage. And if you press the switch, and then pin number 2 will be connected to ground, and then the circuit will be triggered. Okay. And when the circuit will be triggered, the output will be high. The capacitor will charge like this, and it will remain high for this time duration, 1.1 RC, LN3 RC times, and again the output will be low. Okay, and again it will just wait for the next trigger. If you apply again next trigger, again the output will be high for this time, that is RC, LN3 RC times. So this is all about monostable configuration. And another one interesting fact is that suppose the monostable circuit is already triggered and the output is high, and within that duration, that is the output is high or is already high. Within that duration, if you apply a next trigger, the IC will not accept. So it will accept the next trigger when the output will be 0. After that, again, it will accept the next trigger. So this is all about monostable operation of 555 timer. So you can use this type of circuit to design some electronic switches, burglar alarm, like that. So let us see how we can design this in TinkerCAD. So in our TinkerCAD, we shall apply trigger by using some switch. Okay, there are just sliding switches there. We can apply a trigger by using switch, and we shall observe the output in a LED, and we shall check that how long the LED will be on. Okay, and that should be approximately equal to this times, the LN3 RC times. So let us see how we can design that. So I'm going to edit the previous circuit. So this one is our monostable operation using 555. And here we are not, you can use oscilloscope if you can also apply a trigger from a function generator, but so we are going to design a circuit that will be much more practical. So that's why I'm just deleting this oscilloscope. We shall display the output in LED. Okay. So let's delete the unnecessary connections. So you can see that this resistor R1 will be there from VCC to pin number 7. It is okay. And there is no R2. So we can delete this. Okay. And the pin number 2, there will be trigger. So we do not want this. Pin number 2 is not required. We shall apply trigger here. and just check the circuit. Okay, so just go back to our previous circuit. From VCC to pin number 7, one resistor R, and pin number 7 and 6 sorted together on one capacitor C. That's all. Connected to pin number 7. Pin number 7 and pin number 6 will be sorted together. So it will look like this. So delete this wire. Pin 7 and pin number 6 sorted together here. And from pin number 6, we are connecting the capacitor here. See, this is pin number 6, capacitor ground. Okay, now it is fine. The pin number 2 is an apply trigger, and pin number 3 we have to connect one LED. So let's the LED is here. So this one is the anode, this one is the cathode. So, and we have to use some resistor, otherwise the LED may be damaged. Okay, so let I'm just connecting it to a cathode. So let I'm giving 100 ohm resistor. Okay, and this is cathode, this is anode. Okay, so let's connect it to this terminal. Yeah, that means when the pin number 3 will be high, the LED will glow. Okay. Now let's design that trigger circuit. For trigger circuit, we are taking one sliding switch. Just check, so you can move the position of the switch. Okay. This one end will be connected to VCC. Another one end will be connected to ground. I'm going to connect it to VCC. This one. And you know, for normal condition, it will be connected to VCC. And another one end of this, which will be connected to ground. And from the midpoint, this is the output we are taking, and we are connecting it to pin number 2. Yeah, like this. Now check the switch position. It is connected now. It is connected to terminal 1, that is VCC. That is the circuit is in rest condition. Okay, and we have to give some larger value of resistor and capacitor, so that that LED will be on for some time. We can count the duration. Okay, suppose if you take a value of resistor and capacitor, smaller value, see the theory. Okay, if you select 10 kilo ohm and point just 1 nanofarad or 10 nanofarad, it will work. So, but you cannot visualize the LED, means that the LED will be on only for some millisecond duration, and you cannot count the LED, okay, the duration actually. So for that, to get this time period on time for some higher range, so this on time will be some 1 second, 2 seconds, 5 seconds, like that. So we have to use a higher value of resistor and capacitor. So this on time is actually 1.1 RC times. So I'm giving R equal to 1 mega ohm, or 2 mega ohm. Okay, 2 mega ohm. And the value of capacitor, this capacitor I'm giving, so it's mega means it is 10 to the power 6. So if I give it 1 microfarad or 2 microfarad, so 2 mega ohm, 2 microfarad. So mega and micro will cancel each other. So 2 R into C, it will be 2 into 2, around 4. Okay, so 4 into ln3, that is 1 point, ln3 means it is 1.1. So the on time will be 4 into 1.1. Okay, around 4.4 second. Okay, it's around 4.4 second, the LED will be on if I apply one trigger. So let us test the circuit. So you can use a stopwatch. Okay, how long this LED will be on, so you can check it. Okay, what is that? Yeah, see. Yeah, initially when it will run, So the LED might glow because it is a simulation platform. You just apply a trigger like this. Okay, so now the LED is on. You can check. Okay, show, and it is off. So let's count that. So now I'm applying trigger. I'm sliding this position, LED on. 1, 2, 3, 4, 5. Yeah, around 4 to 5 seconds the LED will be on. Apply next trigger. Yeah. See. Now check another one interesting thing. So the LED is already on. It is on. Again, I'm applying next trigger, but it will not accept it. Okay. So it will be off. Then it will accept the trigger. So this is all about monostable operation, and you can increase the duration. I am changing the value of this to 4 megaohm, so 5. So around 10 seconds, the LED will be on. Just ignore the first one. Yeah, again I'm applying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, around 10 seconds, it is on. So this is all about monostable operation using 555 timer. Thank you all.